Okay, so very good morning. And so what we have discussed in last lecture. So we have discussed about the FPGA, right? Then advantages of FPGA, then comparison between the CPLD and FPGA. Okay, and today now we will discuss about the Altera Flex 10K FPGA architecture and its details. Okay, so Altera Altera also manufactured different FPGAs like Flex 8K is there. Then some advanced version of it is like Flex 10K is there. Okay, so these are the FPGAs that are manufactured by this Altera company. And along with this, Xilinx also manufactured many FPGA series, right? And many FPGA families. Okay, but for your syllabus, this Altera Flex 10K is mentioned in your syllabus. Okay, so we will discuss about that. So we have already discussed about the what do you mean by FPGA and what are the advantages of using FPGA. Okay, so now in today's lecture, we will discuss about the actual architecture of FPGA, right? That is manufactured by the Altera, and the series name is Flex 10K. Okay, so Flex 10K Altera FPGA. Today we are going to discuss. So what are you are able to get on screen is a general structure of this Flex 10K FPGA. Okay, so this is a typical architecture of this Flex 10K FPGA. It has different interconnections, then input output ports, then EABs available. Okay, with different macros are also there. So this is the general structure of this Altera Flex 10K FPGA. Okay, now we are going to discuss the specification, or you can say the features of this Altera 10K FPGA. Okay, so the previous series to this Altera Flex 10K is Altera Flex 8K, right? Now some modification and some extension they have developed with this 8K family, and now they have come in the state of art of Flex 10K family. Okay, means this 10K Flex architecture is just modification to the 8K architecture. That is the what we can say basic FPGA that is manufactured by the Altera, that is Flex 8K. Okay, now this Flex 10K offers all the features of Flex 8K with the addition of a variable sized block of SRAM and called embedded array block, that is EAB, embedded array blocks. That means the basic architecture or the 8K architecture is there in this 10K family also, but what additional features it has been provided with. So it is variable sized blocks of SRAM. So this is the additional feature, as well as EABs they have provided in this 10K series. That means embedded array blocks. Okay, so these are the additional features that are provided in this 10K series as compared to 8K. Okay, what are the features of the 8K? It is already there. With addition to that, these are the additional or extra feature you can say that has been provided in this 10K Flex series. Okay, and what is that additional feature? So variable sized block of SRAM is provided in this 10K, as well as embedded array blocks are also there, that is EABs. Okay, what is next feature? It shows that each row in Flex 10K chip has an EAB on one end. Okay, and each EAB is configured to serve as an SRAM block with a variable aspect ratio, for example 256 by 8 to 512 by 4, 1K by 2, or 2K by 1. Okay, that means each row in that FPGA, right, it is provided with one embedded array block and that embedded array block, that means that each embedded array block can be served, or that can be configured to serve as a SRAM block, that is static random access memory, with variable aspect ratio 256 by 8, 500 by 4, 512 by 4, then 1K by 2, and 2K by 1. So these are the different aspect ratio, right? So you can configure that EAB block, that is embedded array block, to serve as an SRAM block. Okay, so this is the extra feature that is provided in this 10K family. Now, in addition, each or and particular embedded array block can alternatively be configured to implement a complex logic circuit, such as multiplexer, right, by employing it as a large multi-output lookup table, right? Means along with this, that means you can use this SRAM uh, EAB block, you can configure to serve as an SRAM, okay, with different aspect ratios. This is the one advantage. Now, in addition, these EABs, that is embedded array blocks, can be alternatively configured to implement a complex logic circuit, right? That means you can actually configure this EAB blocks as a one particular design unit in this FPGA, right? That means it can be configured as a complex logic circuit. For example, multiplex means for example, that particular EAB block of single row can be a single design unit, right? You can configure that block with different complex logic circuits. So this is the additional feature that is provided in this 10K. Now again, what are the features, or you can say merit, of this Altera Flex 10K? So this provides, as a part of their CAD tool, several macro functions that implement useful logic circuit in EAB. Okay, so as a part of their CAD tool, several macro functions can also be implemented using this logic circuits in this EAB, embedded array blocks. Counting the EABs as a logic gates, Flex 10K offers the highest logic capacity of any FPGA, although it is hard to provide an accurate number. That means, as far as this embedded array block is concerned, and if you are going to configure that is as a logic gate only, then this 10K series, Altera Flex 10K FPGA series, offers the highest number of capacity, right, which are available with any of the FPGA that is available in the market. Okay, this 10K Flex series, if you configured each embedded array block as a one gate, one logic gate, then actually the count will be uncountable, right? That means it offers the highest logic capacity of any FPGA that is available in the market. Okay, so this 10K is the, what you can say, a higher end FPGA, more, or you can say this 10K is the higher end FPGA. Okay, whatever the availables in the market. So these are the some prominent features of this Altera Flex 10K FPGA. Okay, now advantages of FPGAs. Okay, we will discuss the advantages of FPGAs. Now, what are the advantages of FPGAs? So fast digital design, no wait to obtaining a target chip. Okay, the speed to design a particular chip, or it offers the fast design speed, fast digital design speed. The design can be implemented on the FPGA and tested at once. Okay, so design can be implemented on FPGA, and by using built-in self-test on boundary scan or JTAG method, you can test the entire design at once. Okay, FPGAs are good prototype. Means if you want to design a new circuit or new complex digital design, then FPGAs are good prototype. Why? Because it is a reprogrammable many times, right? If your design is faulty, or there is a what we can say, error in your design, so you can reprogram that FPGA, and again you can go for testing. If again you find some flaws in that design, then again you can reprogram, or you can modify your design. Again you have reconfigure that FPGA or reprogram that FPGA, and again your prototype is ready. That means these FPGAs are good for the prototyping purpose. After final design, product is so small size. I don't know if you actually see the FPGAs. Actually, it is a very small size chip, right? A very small size chip. Even what we can say, uh, your PIC IC is also kind of bigger than that, right? Depending upon which FPGA actually you are choosing, but as compared to the logic design capacity, speed, and its features, number of gates, number of what we can say program per erase cycle. So if you consider these many features as compared to all these features, but size is very less. So this is the one of the strongest advantage of using FPGA. And the designer can be used the same FPGA more than a design, right? Means the space required to actually implement that design on FPGA is very less, because it's a what you can say array of that particular small gates, right, that are connected with each other, right? So the internal structure is arranged in such a way that the space required to implement any complex design is very less as compared to other hardwares available. So these are the some of the important advantages of FPGAs. Okay, now where you find the application of this FPGA? In your computer CPU, right? Then different digital signal processing cores, DSP cores, then computer architecture experiments, then build the lab test equipment, clock pulse, then different even your DSO. In your DSO also there is a FPGA chip available, right? Then what you can say, the modem controller or LAN controller, there you find the FPGA or ASIC or CPLD, right? In your computer CPLD, then your digital to analog converters, sigma delta digital to analog converters, then telecommunication protocol analyzer, right? There is one device as like your digital oscilloscope, right? So protocol analyzer is one device like your digital oscilloscope. In that you can find one or more FPGAs even, right? Then digital modulators, modems, neural networks. So variety of applications. See, wherever you require a speed, wherever you require a accuracy, wherever you require a fast operation, you should go for FPGA only. Okay, wherever speed is matters, FPGA can serve your purpose. जिथे जिथे तुम्हाला फास्ट ऑपरेशन अपेक्षित आहे, तिथे तिथे तुम्ही FPGA वापरू शकता. समजलं? So these are the application areas of FPGA. Okay, so here we have finished with the unit number 6, that is architecture of commercial devices. So already I have shared the PPTs with you on your group, and I guess last unit PPT also I have shared. Okay, so now from next lecture we will start with the last unit, that is state machines, unit number 4, state machines. Okay, and we will cover that part also. Okay, so this is about the unit number 6, architecture of commercial devices. So I declare this unit is finished. If you have any query, if you want me to repeat some point, okay, you can ask me right now. समजलंय का सगळ्यांना? Are you through with this unit? Are you through with this unit? समजलंय का सगळ्यांना? Okay.
हाँ सर.
So from next lecture, we will start with the next unit, that is unit number 4, state machines. Okay.